Journey to the center of the earth. We live on a world we think we know. We walk its mountains, sail across its oceans, and build cities upon its surface. But in truth, the surface of the earth is nothing more than a fragile shell. Beneath us lies a hidden universe, layer upon layer of rock and molten metal, each stranger and more powerful than the last. This is the story of the Earth's interior, a journey from the crust beneath our feet, down through the mantle, and finally, into the blazing iron heart of our planet. It is a voyage into the unknown, where science, imagination, and mystery converge. The crust, Earth's fragile skin, 70 kilometer deep. Narrator. If the Earth were an apple, the crust would be its skin, thin, fragile, and almost insignificant, compared to the vast interior. It makes up less than 1% of the planet's total volume, and yet, astonishingly, it is here, on this delicate surface, that all of human history has taken place. Everything we have ever known, every civilization ever built, every life that has come and gone, it has all happened on this razor-thin layer of rock. But the crust is not a quiet, unchanging foundation. It is alive with motion, fractured into colossal slabs that drift, collide, and reshape the planet. Beneath its surface, forces far more powerful than any we can imagine constantly push and pull, reshaping continents, building mountains, and tearing open oceans. A shell on a living planet. To understand how fragile the crust is, imagine holding a globe of Earth in your hands. If the Earth were reduced to the size of a classroom globe, the crust would be thinner than the paint on its surface. That is all that separates us from the roaring, molten interior below. And yet, thin as it is, the crust is the stage of life. It carries forests, deserts, rivers, and seas. It supports cities that glitter at night and farmlands that stretch to the horizon. Without it, life would have nowhere to anchor. But we must not mistake this stage for stability. The crust is restless, cracked into moving pieces, each one weighing billions of tons, and those pieces are forever shifting. Two faces of the crust. The crust comes in two very different forms, each with its own character, its own destiny. Continental crust, thick, buoyant, ancient. It is mostly made of granite and lighter rocks, allowing it to float high above the mantle. This is the crust that forms the continents, the mountains, and the valleys we call home. In some regions, beneath towering mountain ranges like the Himalayas, it can reach thicknesses of up to 70 kilometers. Some fragments of this crust are over 4 billion years old, holding the memory of Earth's earliest days. Oceanic crust, thin, dense, and short-lived. It is formed of basalt, created as magma, wells up at mid-ocean ridges and solidifies. But oceanic crust is temporary. Within about 200 million years, a blink of an eye in geologic time, it is forced back into the mantle, recycled in fiery subduction zones. Beneath the oceans, this crust is only 5 to 10 kilometers thick, barely more than a whisper compared to the vastness of the Earth below. Continental crust is like a library of ancient history, preserving Earth's past. Oceanic crust is more like a chalkboard, written upon, erased, and rewritten endlessly. Together, they form the shifting surface of our living world. The puzzle of plates. Though it feels solid beneath our feet, the crust is anything but fixed. It is cracked into massive tectonic plates, floating like rafts upon the slowly moving mantle below. Some plates carry entire continents, drifting apart or colliding over the course of millions of years. Others lie beneath the oceans, constantly forming and vanishing in a cycle of birth and destruction, where plates collide, mountains rise. Witness the Himalayas, thrust upward by the collision of India with Eurasia, where they pull apart, rifts open, and oceans are born, like the widening Atlantic Ocean, which grows a few centimeters each year. Where they grind past one another, earthquakes strike, like those along California's San Andreas Fault. this restless puzzle has been shaping Earth for billions of years, and it will continue long after our civilizations have faded. Mountains, oceans, and scars over time. The crust has been sculpted into breathtaking forms. The tallest mountains, like Everest, rise from the compression of colliding plates. The deepest trenches, like the Mariana Trench, mark places where oceanic crust is swallowed back into the mantle. Rift valleys, like Africa's Great Rift, are scars of the crust being torn apart. These features remind us that the crust is not permanent. Continents wander. Oceans open and close. Landscapes rise and erode away. What seems eternal to us, mountains, coastlines, even continents, are temporary expressions of a much deeper cycle, a fragile stage for life, and yet for all its instability, the crust is where life thrives. The soils that grow our crops are formed from the breakdown of crustal rocks. The rivers that carry fresh water are carved into it. The minerals we mine, gold, silver, copper, iron, all come from it. Civilizations have been built upon this crust, drawing wealth and shelter from it, but also suffering from its wrath. Earthquakes have toppled cities in moments. Volcanic eruptions have buried towns, darkened skies, and even changed climates. We live at the mercy of this fragile stage. The same crust that feeds us can, in an instant, destroy us. Fire from below, when tectonic plates pull apart. Magma from the mantle rises to fill the gap, creating new crust. At mid-ocean ridges, this process is constant. Vast underwater mountain chains stretching thousands of kilometers across the seafloor. On land, rifting can give birth to great valleys and volcanoes. The very ground beneath us can split open, birthing new land where none existed before. But when plates collide, the story is different. Oceanic crust, dense and heavy, plunges beneath continental crust, melting and sending up towering volcanoes. The fiery arcs of the Andes and the Cascades are born from this cycle of destruction and renewal. The crust is not simply a passive shell. It is dynamic, creative, and destructive. A thin film where Earth's deep interior meets the open sky. Record of time. The continental crust is also a record of Earth's deep past. Some rocks, billions of years old, carry the scars of ancient collisions, the chemical fingerprints of long-vanished oceans, and the fossils of early life. In Greenland, in Canada, and in Australia, fragments of the earliest crust still survive. Relics of a time when the young Earth was still cooling from its fiery birth. The oceanic crust, by contrast, is always young. None of it older than 200 million years survives, erased and remade in the great recycling system of plate tectonics. Together, these two faces of the crust preserve both the memory of Earth's beginning and the restless cycles of its present. Humanity's exploration of the crust. For most of history, the crust was a mystery. We lived upon it, mined it, built upon it, but how thick was it? What lay beneath? Seismology, the study of earthquakes, gave us the first answers. By studying how seismic waves moved through the Earth, scientists mapped the thickness of the crust and discovered the moho. In the 20th century, bold projects attempted to drill into the crust itself. The most famous, the Kola superdeep borehole in Russia, reached a depth of 12 kilometers, the deepest hole ever made by humans. And yet, even at this depth, it pierced only a fraction of the crust. The attempt showed us something humbling. For all our technology, we have barely scratched the surface of our own planet. The restless skin of Earth's crust is fragile, restless, and temporary. Continents drift. Oceans open and close. Mountains rise and crumble. To us, these changes take place over incomprehensible spans of time. But to the Earth, they are the steady rhythm of life. The crust is a paradox. It is thin, yet it carries the weight of oceans and continents. It is fragile, yet it has withstood billions of years. It is unstable, yet it has nurtured the stability needed for life. It is the skin of a living planet, forever changing, forever renewing, and forever reminding us of both our vulnerability and our resilience. The Mohorovičić discontinuity. The first gateway, in 1909, a Croatian scientist named Andrija Mohorovičić studied the way seismic waves traveled after an earthquake near Zagreb. He noticed something peculiar. At a certain depth, the waves suddenly sped up. The explanation was revolutionary. Beneath the crust, Earth's material must be different, denser, harder, less forgiving. This invisible frontier became known as the Mohorovičić discontinuity, or simply the MOHO. It was the first time humanity realized that Earth is not uniform, but layered like an onion, and the MOHO is the doorway to the vast and mysterious mantle. The upper mantle, a moving engine, 70 410-kilometer deep. Descending past the MOHO, we enter the upper mantle. Unlike the brittle crust, this region is strange. Its rocks are solid, but under the crushing pressure and intense heat, they flow ever so slowly. Imagine honey left in the cold, firm, but still able to creep and shift over time. It is here that we find the asthenosphere, a soft, ductile zone that behaves almost like a river of rock. This is where the dance of plate tectonics begins. The plates of the lithosphere float on this soft foundation, moving a few centimeters a year, just as fast as our fingernails grow. Yet these small movements carry immense consequences. Entire continents shift. Oceans open and close. Volcanoes erupt. The face of the planet is reshaped, driven by the restless engine of the mantle. Without the asthenosphere, Earth's surface would be static, lifeless, motionless. Instead, our planet breathes, transforms, and evolves. The transition zone, the shapeshifter, 410, 660-kilometer deep. As we travel deeper, we enter the transition zone, a place where minerals themselves change their identity. Here, the mineral olivine, abundant in the upper mantle, is transformed by crushing pressure into new crystalline forms. The atoms rearrange themselves, building new structures more resistant to the brutal forces of the deep earth. This zone acts like a barrier, a reservoir, and perhaps even a hidden ocean. Scientists believe that vast amounts of water, more than all Earth's surface oceans combined, might be trapped inside minerals here, locked away for billions of years. The transition zone is a reminder that Earth is not static. Even its rocks live and change, bending under pressure, morphing into new forms to survive the depths. The lower mantle, the giant within, 660, 2890-kilometer deep. Below the transition zone lies the lower mantle, the single largest part of Earth. It makes up 84% of the planet's volume, an unimaginably vast kingdom of rock. Here, the pressure is millions of times higher than at the surface. Temperatures soar to over 3,000 degrees. The rock is solid, but it flows ever so slowly, carrying heat from the deep earth toward the surface. It is in the lower mantle that one of Earth's most powerful forces is born: mantle plumes. These are colossal columns of superheated rock, rising like fireballs toward the crust. When they break through, they create hotspots, places like Hawaii, Iceland, and Yellowstone. Sometimes these plumes feed supervolcanoes, whose eruptions can alter the planet's climate and even threaten civilizations. The lower mantle is a giant, silent, hidden, yet it shapes the destiny of the world above. The mesosphere and the mysterious D layer between the asthenosphere and the core lies the mesosphere, a region less studied but no less important. But what truly fascinates scientists is the D layer, pronounced D double prime, lying just above the core. This mysterious zone defies our expectations. Here, rocks behave in ways never seen before, some melting, some solidifying, some doing both at once. It is thought to be the birthplace of mantle plumes, the fiery engines that rise toward the surface. In many ways, D is the Earth's hidden factory, one that drives geological power on a scale we are only beginning to understand. The core mantle boundary, the Great Divide, at about 2,890 km deep, we reach a dramatic frontier, the core mantle. Boundary. Seismic waves reveal the truth. P waves, compression waves, suddenly slow, while S waves, shear waves, vanish entirely. This tells us that the next layer is not solid but liquid. We are about to enter Earth's metallic heart. The outer core. The planet's dynamo, 2890, 5,150 km deep. The outer core is a vast ocean of molten iron and nickel, churning violently, in constant motion. As this liquid metal swirls, it generates electric currents. And from these currents arises one of Earth's greatest gifts, the magnetic field. This invisible shield stretches far into space, deflecting the deadly solar wind and protecting Earth from cosmic radiation. Without it, our atmosphere could be stripped away. Oceans would evaporate. Life as we know it might never have existed. The outer core is more than molten metal. It is the dynamo of life. The inner core boundary, the frozen heart of fire deeper. Still, the pressure becomes unbearable. The weight of the entire planet presses down. At around 5,150 km deep, molten iron can no longer remain liquid. It crystallizes into solid metal. Here lies the boundary between the outer core and the inner core, the frozen heart of fire. The inner core, Earth's blazing heart, 5,150, 6,371 km deep. At last, we arrive at the very center of the Earth, the inner core, a solid sphere, of iron and nickel. Its temperature reaches 5,500 degrees C, as hot as the surface of the sun. Yet the crushing pressure keeps it solid. It is Earth's beating heart, immense, mysterious, and vital. Strangely, the inner core does not move in lockstep with the rest of the planet. It appears to rotate independently, slowly drifting ahead or lagging behind the surface. This strange motion may influence Earth's magnetic field, the length of our days, and even the long-term future of the planet. The inner core is a paradox, both solid and dynamic, ancient and alive. It is the secret heart that has burned for billions of years and will continue burning long after we are gone. The journey completed, from the fragile crust beneath our feet to the blazing iron sphere at Earth's center, our journey reveals a planet alive with hidden forces. The crust gives us land and ocean. The mantle moves continents and births volcanoes. The outer core shields us with a magnetic field, and the inner core pulses at the heart of it all. Earth is not a dead rock in space. It is a living machine, forever in motion, forever changing. Thor. Journey into Earth's interior is to journey into the story of our own existence. For without these hidden layers, there would be no continents, no oceans, no magnetic shield, no life. Beneath our feet lies not just stone and fire, but the very foundation of who we are.